All right. So this is part 2 of the review. Let's see if it's hopefully it's recording my stuff here. I think it's working. Yeah, we'll see. I guess when I watch it later, might just be mute. Well, let's see. Anyway, so the only thing I'm going to ask for 2.4 is net change. Well, two things. First thing is net change. So let's do one of those real quick. I'll just pick a random one from the homework. Two x squared minus x. From x equals, let's say, 1 to 2, I guess. 1 to 2. Yeah, 1 to 2. All right. So net change is equal to f of b minus f of a. And then in this case, a is the starting point, b is the ending point. So that will be f of 2 minus f of 1. So that will be 2 times 2 squared minus 2. So I'm going to put it in brackets so you see that this is the f of b piece, right? Minus the f of a piece. This is going to be 2 times 1 squared minus 1. So this result will be what? 2 squared times 2. It's like 6, right? 8 minus 2, 6. Yeah. 1 is 1 times 2 minus 1. That'll be 5. So that's all you have to do for net change. Okay. Second thing for that section will be average rate of change. Find the average rate of change of f of x equal to, I don't know, take one of x squared plus 2x plus 1 from x equals 0 to x equals 2. Right? All right. So find out, let's label everything, but first write down the formula. Average rate of change is equal to f of b minus f of a over b minus a. So identify the a, identify the b. I want to just plug them in, right? So I'm going to do it over here. There's not enough space. So plug in the 0 first. into F. Sorry, 2 first, my bad. 2 squared plus 2 times 2 plus 1 minus 0 plus 2 times 0 plus 1. What is this going to be here, this piece? So let's see. Yeah. So 9 minus, this will be divided by so the average rate between 0 to 2 is 4. So that's all I'm going to ask for 2 for. Any question on net change or is it all right? Okay. Move on to 2.5 then. Or sorry, 2.6. The fraction type? Sure. Like 1 over x something. Let's do 21 on the homework. You guys cool on this page? All right. Example 3. Find the average rate of change of f of x equal to 1 over, I don't know, let's say x plus 2. Is that what you're asking for? One of these times? Yes. Okay. From x equals, let's say, 0 to x equals, I don't know, 3. All right. So this is my A. This is my B. Average rate of change is equal to f of B minus f of A.
Sure.
Yes.
How do you know which one's going to be
A will always be the starting point, the lowest one.
the first X?
Yeah, the first X. So if they say like from -3 to 7, -3 will be the A. Okay. Will always be the smaller or more negative. Okay, so here we go. Plug in your B. So that will be 1 over 0 plus 2 minus.
B is 3.
Oh, yes, thank you. B is first, my bad. Just testing you guys. No, I'm just kidding. So plug in the B first. Minus the A. And then 3 minus 0. B minus A. You guys still with me to this point? So we're gonna get, let's go ahead and go down here. This will be 1/5 minus 1/2, right? Combine those fractions with the same LCD. What's the LCD of 5 and 2? Maybe 10. They're both prime, so just the product will be fine. So LCD will give me a 10 with this guy. This one needs a 5. That'll be 2 over 10 minus 5 over 10. And technically there is a 3 that I forgot about. So I'm just going to put over here. So 2 minus 5, what's that going to be? -3, so this is -3 over 10 divided by 3. Which is the same as -3 over 10 times 1 over 3. So it's the same type of thing, it's just that you may have to deal with fractions. Okay. I think in the homework they might throw in a letter instead of a number. I'll let that mess with you, it's the same thing. Okay. Any questions on this problem? Is it okay?
It's the same way on the three.
Yeah, then that would just be this top part, the -3/10. All right. That's cool on this page. Any questions on net change or average rate of change? Seven or 6? Don't want to get asked about 2 things here as well. First thing is know what causes vertical, horizontal, and vertical horizontal shifts. So know what causes vertical / horizontal shifts and reflections. So I'm just going to make up a question right now. Find a function no, actually. Find the equation of a function that is quadratic shifted up 2 units, shifted to the left 4 units, and reflected across the x-axis. So you just gotta give me the function that does all this. And then there's more than one answer, but I recommend giving me the easiest one. Don't be weird about it. So basically I'm asking for a parabola that's been moved 2 units up, 4 units to the left, and then reflected down. So what function does that? I think this will help. I'll leave some blanks for you. That'll help, right?
X plus 4 squared plus 2.
Yeah. So the minus reflects it, plus 4 shifts it this way, right? And then plus 2. Yeah, you got it. Find something like this on your test for sure. I might ask for cube or square root. It's going to be the exact same thing, it's just a different function, right? So instead of a square, you might have a 3 or square root. Is it clear as to what I'm asking here?
Is the negative what makes it reflect?
This minus, yeah, reflects up and down. Yeah. So if you were to graph it, it'd be over here 1, 2, 3, 4, 1, 2, opening downward, something like this. So assuming that the original would be in the middle, up to 4 units this way, minus. Any questions on number 1? Yeah. So as long as it's outside parentheses, it's going to be up and down. If it's inside, it's going to be the opposite, but horizontal. So plus 4 is left, minus 4 is to the right.
Excuse me.
Yes,
Isn't this final equation of a function that is what?
quadratic. Yeah, so I could change that to cubic or something else. Okay. So the other thing I'm going to ask from this section, even, odd, neither. So determine if the function f of x equal to Even odd. Where is that? Maybe that's to make one up. Determine if this function is even, odd, neither. So pick one, and we're going to show it by plugging in negative x. Okay. Now here's some notes just in case you forgot. Even means this. If you plug in a negative x, it's as if you plug in a positive. So no real change. This is definition of even. If you plug in a negative x and you get the exact opposite that you started with, like the sign just flip, every single one flips. This is the definition of odd. So what you're gonna do is plug in the negative x, see what happens. Right? So first one becomes just a regular x squared, right? Negative negative becomes a plus. That one just stays a one. Is this the exact same thing I started with? Here's the original. Yeah, it's not the same, so it's not even. So now the next thing we should ask ourselves, is it the exact opposite of this, sign-wise?
No.
It's not, so it's neither, is it? So this function is neither odd nor even. That makes sense? That's all you gotta do. Is plug in negative x and see what happens. Okay. Any questions on even or odd? Yep. You cool on this page? Determine if it's even, odd, or neither. X cubed plus x. Yes. Yeah, you're gonna plug in the negative x to test it. Is that what you asked? Yeah, plug it in. Negative x cubed plus negative x. Since it's odd, it's going to stay negative, right? It's going to become negative. You're going to get negative x cubed plus negative is just the same as minus x. So it is the exact opposite sign-wise from the original, right? So since f of negative x is equal to negative f of x, then f is odd. Any questions on that? That's what I mean by the definition. This is what the definition means. Negative f means all has switched. Okay. You guys cool with even and odd? We'll move on to 7, unless you have a question. Okay. So let's do 2.7. I think it was the algebra of functions and then the composition stuff. Okay. I think this is one of the harder sections. Combining functions. So number 1, the first main idea is find f plus g, f minus g, f times g, f divided by g, and their domains. So example 1, let me pick one from the book. Yeah, I think I did this earlier. F is equal to 25, the square root of 25 minus x squared. G is equal to square root of x plus 3. So we're going to go find f plus g, f minus g, etc. But we're going to need their domains. So what I recommend before you start is determine the domain of f. You can do it, you can solve for it or you can graph it. Doesn't matter. You can also try to think about it. Right? If the inside must be positive, we can solve for that inequality, right? Move that 25 over. Divide by a -1. That flips over the inequality. Square root both sides, and you get x must be less than 5. But also, you have to tack on that minus, right? Plus or minus. So when you do that, the sign will flip. So it needs to be greater than or equal to -5. So 4. So if you don't want to do this, you can graph it. It's fine. Now you're gonna. It's not a big deal. If you are familiar with this equation, you should see that it's a circle. It's the top half of the circle, meaning it's restricted between -5 and 5. Right? So radius 5. If you didn't see that it was a circle, that's cool. But you'd have to do it this way or graph. So the domain will be -5 to 5. Yes. Huh?
X3 minus 5, or you talking about
This one, it's right here. Oh, my bad. Yeah, so this is saying that x must be below 5. This must be above -5. So
The top two or what
the square?
but it looks like the X
Yeah, this is x squared. Yeah. Is that what you're asking about?
goes down.
Here?
That way.
This one? Here.
The greater than.
Mm. Then it's not legible, is what you're saying. Gotcha. X is less than or equal to 5, or x is greater than. This couldn't fit my hand in here. Greater than or equal to -5. Yeah. So that's the requirement, right? Inside of square root, you can never be negative. It can be 0 or bigger. So that's what we start with. Make the assumption. We want to know what keeps it positive. So you solve it and you find out, well, as long as I'm here or there, I'm good. Yes.
And in which case it will be like x is less than or equal to -5, but x is greater than or equal to 5. Like from negative infinity till -5, and then union 5 till infinity.
Yeah, if they were both pointing like outward, yeah, you could do it that way. But this one, it's enclosed.
Like how the equation, like how it will be.
Like if you had 5 or greater or 5 or below,
Yeah.
it would be probably one of these. Something like this. I would have 2 different intervals at the pole. So -infinity till 5, and then 5 to infinity would be fine, but not 5. But this has a small section. Let me show you the picture. I mean, think about it, right? You plug in a -5, it's going to be squared, which would be 25. So which will be 0, right? 25 minus 25. So I can't go below -5 because I'll get, let's say I put -6. You're going to get 25 minus 36. Plug in +6, you get the same thing. So you got to stay in there.
Didn't you say f of x domain doesn't even matter? It's just the g of x domain that matters?
For composition, well, for the composition, yeah. But here we're doing the plus.
What if it was like x squared plus 25, or x squared minus 25, not the whole square, 25 minus x squared? We started with x squared.
That x squared minus 25?
Yeah.
It would be, just for fun, right? You're saying if we had this going on, it, yeah, it's going to be everything outside, but the inside will be a problem. Let's solve it. Yeah. All right, guys. Any other questions? Where was I? Okay. So you can graph it if you want, or you can do this. what is the domain of G? Yeah. The smallest number I can plug in is -3. I gotta stay above. We can. So this is my side work for the first one. So it'd be x plus 3 must stay positive. Solve for x, it will be greater than -3, which gives you this interval. So you can always do this whenever you want. Okay. You can always graph it too. Now, remember in the notes we said find the domain of f plus g, f minus g, f times g. They're all the same, but you need to find where they overlap. Where do these two sets overlap? Yeah. So domain of f plus g is what they have in common, right? That's what we said on the notes. So where A intersects B, in other words, the elements that have in common. So this right here is this note. You remember? Yeah, for the first three, it's going to be that answer.
Oh, okay.
So we don't have to do this anymore. So f plus g, f minus g, f times g, same thing, same answer. So I guess we'll do part B. You should have put part A there. So this was F plus. I didn't write it. Sorry about that. Any questions on number one or the first part? So F minus would be pretty straightforward. So that's simply just this, and you're done. You can't combine them. So that's it. And then the domain is the same as the first one. So once you do it, once you do all this work up here, the rest come out pretty quick. Any questions on part B?
Like, do we still have to show all our work for people? At times these,
The work for which one? Which part?
for each one, because you said like basically each one, -5. You
Yeah,
still have to
for-
show like the work for every single.
Now, once you do it once, you can just write this down.
Okay.
The only work you'd have to show is maybe if this simplifies,
Okay.
but this is not going to simplify, right? F times G is multiplying together. So that will be the square root of 25 minus x squared times square root of x plus 3. Yeah, I'd be fine if you left it that way, but you could combine them technically. Because this is the same as saying this first argument times the second one. But you don't have to. Domain's the same thing though, so that's good. The only time it changes is the division. That one we have to be more careful. F divided by G. Any question on B or C? I'll wait a bit before I turn it. That's cool. No rush, of course. All right, so part D then. So f of x that will simply be the division of both functions. The first one was 25 minus x squared, right? I think that was it. So the domain will be very similar. You just have to exclude whatever makes the bottom 0. So what makes the denominator 0 here? Yeah, we can solve for it just to be safe. Well, we want to know when it's 0, so we don't need the greater part. But you could. So this is a problem, right? So earlier we had the domain include -3. Now I'm telling you that you cannot. So what is the answer? Yeah. Just take off the bracket. So the bottom part, we want to know what makes it 0. So you can solve for it and find out. Only the bottom will cause division by 0, which is a problem. We don't care if the top is 0. We only care if the top is negative. But we already took care of that earlier. So we just have to check one more restriction. Divide my birthday cake by 0. It's confusing. Cut it into 0 pieces. That means I can give out infinite pieces, right? Anyway, any questions on the algebraic functions? Plus, minus, times, division. Can you do these operations? Subtract, plus that. Guess I can jam it in here. There's nothing else to do other than just plus them together. They don't combine. We're going to move on to composition if you're okay with it. All right. The second point of this section, find f of g and g of f and their domains. let f of x equal the square root of x. G of x will equal square root of 2 minus x. So before you do compositions, we should find the domain just to be safe. What's the domain of f? Yeah, 0 is cool. And everything above, right? And if you want to know how you find it, well, the inside must be greater than 0, and that's all you can do. This determines this. Same thing for this guy. 2 minus x must be greater than or equal to 0. So subtract by 2, divide by negative, and you get that it's flipping to the right. So everything must be below 2. And you can always graph it like I said. Yeah, negative infinity till 2. Hopefully you guys are more comfortable with domain since it's 2.1. Because you're going to need it for this section. And any questions on this stuff here? Can't really start until you have it. All right, part A, find f of g and its domain. So f of g is equal to f of square root of 2 minus x, which means that this whole thing is going inside there, right? So when I have the square root of a square root, this looks kind of weird. But it's still legit, it's not wrong. Do you remember what roots are? As powers. Yeah, so this is simply a 1/2 to another half, right? So we think of it this way. That's 2 minus x to the 1/2, and then again, 1/2. But back in, way back when, you have a power to another power, what do?
Multiply the denominators.
Yeah, you just multiply them straight up, but which, yeah, would end up being 1 times 1 over 2 times 2. So that would be 2 minus x to the 1/4, or if you prefer 4th root of this guy. Now, we've been saying that the inside must stay positive. That is true for any even root. It is not true for odd roots. So second square root, 4th root, 6th root, etc. No negatives. Cube roots doesn't care. Odd roots don't care. Right? This is still even, so it has the same restriction as this guy. Right? So remember in the notes I told you to find the domain. That's the next step. We found bug. That part's good. To find the domain, we look at the one that went inside. What is the restriction of this guy? What is the domain there? Right, that's what we found it first. Is this domain the same as this domain? The resulting? Does this have any new restrictions? Or is it the same? Yeah, it's the same issue because it's even, right? So this domain is the same as the original. they look different when you graph them, but they start and go over the same x values. Okay, the y values will be different, but the domain values are the same. Now, if you're to graph both, let's say you're like, you know what, I don't see it. What are you talking about? First one was 2 minus x, right? We said everything below 2 was fine. So that was the domain. I'm going to use 1/4 power just because it's a little easier to type. Doesn't matter. Notice how they're covering the same x values, but they don't look the same. Right? Same domain, same restriction, because they're both even roots. Anyway, any questions on that? So then the domain of the composite, what would it be? Or we say we take this into account, the one that went in, and the new and the new restrictions of the results. But since they're the same, the domain won't change. So we'll just use the one of G. So we can always just look at the G if the new one has no new restrictions or has no restrictions. Doesn't matter. But anyway, it'll be this.
Yeah, so plus this will be from 0 to 2.
If it was odd, like if this was an odd power,
Yeah.
if the result was odd, right?
Yeah.
If the result was odd and we still had the same inner domain, then we would only use, let me show you. Let's say we had a third, right? Notice that now it goes both ways, right? But the G that went inside only goes that way, which means that we have to only allow values from here to the left. So we're going to disregard all these. This is if the new one had bigger domain, it must be restricted by the one that went inside. Okay. But if the new one results in more restrictions, then you got to incorporate them. So the easiest way to think about it is to find the domain of G and see what that has in common with this new one. And that overlapping stuff is the domain, is the answer. Okay. But here they turn out to be exactly the same, so they overlap everywhere. So same thing. Same thing. Any questions on that? We're going to do the other direction in a second. Does that make sense, or starting to a little bit? You guys cool on this page? All right, so part B is find GOP and its domain. So now we're going to care about the F, because that's the one going in, right? Find GOP and its domain. All right. So that means plug in the F, which means we're plugging in root X into this one, right? I'm going to write up here what F is in just a second. plugging in f inside the g, this x value here. Okay. You guys cool up to this point, right? Maybe. So we look at the domain of the one that went inside. The inside must stay positive, right? What is the domain of the results? It's no longer the same, right? And if you don't see it, because it's a weird looking function, so you can solve for it over here. So the inside must stay greater than or equal to 0. Subtract the 2. Divide by negative. Square both sides. X must be less than 4 for the inside, for this new result. But the f going in must be above 0. See that? So what do they have in common? That would be your answer. 0 to infinity and 4 to negative infinity. Where do they overlap? And if you don't see it, you could graph it or create 2 number lines. It's up to you. What is the domain of Goff is what I'm trying to find by looking at the domain of this result. But this one says it must be above 0. So it needs to be above 0 but below 4. You see what I'm saying?
So 0 to 4.
0 to 4. Yeah, exactly. It's not as complicated as it seems, right? Once you start to see it, it sounds weird when you're thinking about it. But they only overlap exactly at 0 to 4. So if we were to graph the original, this was the result, the red one, right? It's gap between 0 and 4. The one that went inside, let me change the notation here. We'll call H the new one that we made. And this one was called F, right? So I don't confuse myself or you. F is the one that went inside. So I need to incorporate this domain, which is 0 to infinity, right? 0 to infinity keeps going. But then the red one says, no, I have a new restriction once I created it. So it must stay between 0 and 4. So what they have in common. That's your answer, 0 to 4. So visually, that's what we're doing. Okay. Does that make sense?
So we don't have to simplify that answer anymore. 0 to minus square root of the other one.
Talking about this one?
Yeah, we don't have to simplify that anymore.
No, I don't think you could. Yeah, you can't. No. No, there's no special technique to make it any prettier. It's gonna stay like that. You can change it to fractional powers if you want. That's about it. Yeah. Can't do anything. It's tempting because it looks nasty, right? But yeah. Any questions on A or B? Composition making sense? Hoping you've started it or almost got there. pretty much it for 2.7. What I want to see, stuff I'm going to ask about again, is the algebra type, plus, minus, etc., and their domains, and then the composition and those domains. And that's it for 2.7. Okay. Do you have any question on those topics? We're almost out of time.
What are we doing Friday?
Friday, we're gonna finish. We're not done yet. We got one more section. So I think Friday we'll probably finish it really quick. So I'll leave the rest of the time for homework questions or any concern you might have. Okay. You guys want to stay for about 10 to 15 minutes? Feel free. If not, you're welcome to head out. We'll stop in the lecture here.
When is the?
Homework will be due a few days after the exam. I'm going to put a due date in Canvas, and you're going to see that. You see where it says homework 1, right? And then the homework 1 will have it 16, 17, something like that.
Okay.
Just like one big file.
Yeah, upload one big PDF.
Is this one you need to solve it graphically, like this simplified, or?
I think they just want to show the picture of another one. So, what section are you in? No.
2, 3.
Hey, I read it.
In high school, we used to, that's how we did our math, was they gave everyone iPads in high school, so, but we didn't have Apple Pens, that was cool, we could do it with the finger.
Oh, wow. Yeah, Apple Pen is nice. I like it. Okay, so you solved it. So here's, I mean, there's no,